Assalamu alaikum. My name is Erin Ali. Today the topic of my practical presentation is theory of testing method in sugar industry. First of all, objective. Testing method in sugar industry are crucial for ensuring the quality, efficiency and safety of the production process from sugarcane reception to final product packaging. These tests are broadly categorized into chemical, physical and microbiological analysis. Here is the theoretical basis behind these testing methods. First, introduction to sugar industry testing. The sugar industry involves the processing of sugarcane or sugar beet into raw and refined sugar. Testing is essential at all stages to control production parameters, assess sugar content, ensure product quality, monitor environmental impact, e.g., water waste. Second, key testing method and their theory. A polarity test. The polarity test is a key quality control method in sugar industry used to determine the sucrose content of sugarcane juice, syrup, or sugar crystal. It is based on the optical rotation of polarized light caused by sucrose molecules. Principle of polarity test. Sucrose is optically active. It rotates the plane of polarized light. A polarimeter measures this rotation, which is then related to sucrose concentration. The more sucrose present, the more the light is rotated. Material and equipment required. Polarimeter or scarimeter, polarimeter tube, clarifying agent, filtering paper or filtration unit, sugarcane juice or sample solution, miring cylinder, glassware. Standard procedure for polarity test. First, juice clarification, purpose to remove non-sugar impurities, coloring matter proteins that interface with light transmission steps. Take 100 ml of sugarcane juice or sugar solution, add about 5 to 10 ml of basic lead acetate solution as a clarifying agent. Mix thoroughly. Let the mixture stand or filter through filter paper to obtain a clear solution. Fill polarimeter tube. Fill the clean polarimeter tube with the clarified filtrate. Ensure there are no air bubbles and close both ends tightly. Measurement. Insert the tube into the polarimeter, align and calibrate the instrument. Read the angle of rotation directly from the scale. अच्छा जी, कैलकुलेटिंग पोलैरिटी सुक्रोज कंटेंट यूज द शुगर इंडस्ट्री स्टैंडर्ड फार्मूला जो कि है टेक्स पोलैरिटी इज इक्वल टू फ्रैक्शन टेक्स रीडिंग डिवाइड बाय टाइम्स 100 26 डिवाइड बाय टेक्स लेंथ इन diameter. For a 200 millimeter tube, 2 centimeters is equal to 2 decimeter and standard weight solution direct reading often give polarity percentage. In practical, many labs use standard polarity tubes or digital sketchimeters which display the result directly in polarity percentage. Precautions. Ensure the solution is clear and free of suspended matter. Avoid air bubbles in the tube. Calibrate the instrument properly before use. Maintain standard temperature, usually 20 degrees Celsius during measurement. Second, Briggs test. The Briggs test is a fundamental practical method used in sugar industry to measure the total soluble solids in a liquid sample, primarily sugars. It is expressed in degree Briggs, where 1 Briggs is equal to 1 gram of sucrose in 100 gram of solution. Principle of Briggs test. The Briggs value is determined by measuring the refractive index of sugar solution, usually a refractometer. The refractive index increases with the concentration of dissolved solid like sucrose, apparatus and materials. Refractometer, sugarcane juice or sugar solution, filter paper or muslin cloth for juice clarification. Tissue or lint free cloth, distilled water, dropper or pipette. Procedure. Sample collection. Take a fresh sugarcane juice sample from the mill or processing line. Filter the juice using a muslin cloth or filter paper to remove solid particles. Second, prepare the refractometer. Clean the refractometer prism surface with a distilled water and a soft cloth. Calibrate as or zero the instrument using distilled water. Wipe it and dry with a tissue or lint-free cloth. Sample application. Using a dropper, place 2 to 3 drops of the filtered sugarcane juice on the prism of refractometer. Close the cover plate to separate the sample evenly over the prism. Measurement. For handheld refractometer, look through eyepiece toward a light source. Read the value at the boundary line between light and dark areas on the scale marked in bricks. For digital refractometer, press the read button. The bricks percentage will appear on the display. Recording result. Note the bricks value at EG is 18.5 bricks, which indicates the total soluble solids in the juice. Precautions: ensure no bubble or pulp are present in the sample. Maintain standard temperature. Use temperature correction if needed. Calibrate the refractometer daily for accuracy. Always clean the prism after each use to prevent cross contamination. Use of bricks in sugar industry. Estimate sugar yield. Monitor juice concentration at various processing stages. Determine can quality for farmer payment. Optimize evaporation and crystallization processes. See purity calculation. Purity is crucial parameter in sugar industry that indicates the proportion of sucrose in the total soluble solids in a sugar juice or syrup sample. It is expressed as a percentage, and higher purity means a high concentration of sucrose relative to other solids like reducing sugar, salt, and organic matter. First principle of purity calculation. Purity is calculated using the simple formula: polarity is equal to percentage of sucrose, Brix is equal to total soluble solid. This ratio shows how pure the juice or syrup is in terms of sucrose content. Apparatus required: polarimeter, refractometer, filter paper or cloth, glassware, calculating device, or manual method. Step by step procedure. Measure Brix. Use a refractometer to measure the Brix percentage of juice syrup. Example: Brix is equal to 19.0%. Measure polarity. Clarify the juice sample using lead substrate or similar clarifying agent. Measure polarity using a polarimeter. Example: polarity is equal to 17.1%. Apply the purity formula. Interpretation: 85% good quality can juice, 90% ideal for efficient sugar recovery, 80% indicates impurity on early stage can. Deep moist content. Moisture content analysis is crucial in sugar industry to determine the amount of water present in sugar cane, biogas, or final sugar crystals. It directly affects storage stability, processing efficiency, sugar yield, and purity. Principle of moist content test. The test is based on the loss of drying (LOD) method. A weight sample is heated at a controlled temperature, usually 105 degrees Celsius, and the loss is weighed is considered moisture loss. Equipment and materials. Weighing balance, drying oven, silica or metal moisture dishes or crucibles. A desiccator, sample, tongs or gloves. Step-by-step procedure. Prepare the sample. Take about 5 to 10 gram of well mixed representative samples. Place it in a clean, dry and pre-weighed dish. Weigh the sample. Weigh the dish plus sample together. Record as V2 weight of dish plus wet sample. Dry the sample. Place the dish in a hot air oven at 105 degrees Celsius for 2 to 3 hours or until constant weight. Remove and cool it in a desiccator to avoid moisture reabsorption. Final weighing. Weigh the dry sample plus dish, record as W3. Moisture content calculation. Moisture content is equal to fraction V2 minus V3, V2 minus V1 divided by 100 times. Typical moist ranges: sample type typical moist, sugarcane 70 to 75%, bagasse 45 to 55%, final sugar less than 0.10%. Other tests in sugar industry. Reducing sugar test based on fillings or Benedict's test where reducing sugar react with copper ions to form a red precipitate. Purpose: identifies glucose and fructose content which affect crystallization. pH and acidity. Measure hydrogen ion concentration using a pH meter or an indicator. Monitor fermentation risk and corrosion potential in process equipment. Ash content determines inorganic residue left after burning the sample at high temperature. Indicates the amount of mineral and inorganic matter in sugarcane. Color analysis measure the absorbance of sugar solution at specific wavelength. Grading of white sugar based on color units. Sediment and clarity test. Physical absorption or use of turbidity matter. Check for suspended impurities in sugar or syrup. Importance of testing in sugar. Ensure constant product quality. Help in process optimization. Reduce production losses. Ensure fair payment to farmers. Advanced techniques. High performance liquid chromatography for precise sugar profiling. Atomic absorption spectroscopy for detecting heavy metals. Near infrared spectroscopy for rapid quality analysis. Applications: raw material, process quality, product quality, efficiency and optimization, water management, future recommendation for testing in sugar industry, modernizing testing method, focusing on value added product, improving overall efficiency, addressing specific challenges. This is all about the practical.